The title of the discussion is obviously geared towards talking about opportunities with the current and future missions. One particular aspect of that we thought would be valuable to emphasize is the opportunities for exploring links and synergies between the different missions. So that could be opportunities for coordinated observing of targets, coordinated analysis of targets, looking also as well about lessons we can learn from current and previous missions for thinking ahead for the future missions. This morning, you've already heard talks from Heike, from George, and also from Martin about Plato, TESS, and K2. So you already can put names to faces to those three people. If maybe before I hand over to Hans, who's going to kick off the discussion, if I could maybe just ask all our other representatives here, maybe just to very briefly, just introduce themselves, and then we'll kick off the discussion. Okay.
No microphone. I will pass this on.
Just pass it now.
Yes. Okay. Can we? So if I should start, where is my? Okay, I will just briefly give a short overview of Bright Constellation. My role in this project is I am the chair for the ground-based observations team to support the Bright observations, and I'm representing BEST members, although Jamie Matthews is here as well, so he's also a BEST member. And just for those of you who are not familiar with the Bright Constellation mission, Bright Constellation consists of a fleet of 6 20 centimeter cube nanosatellites, each of them 7 kilos in mass. It's 2 satellites per country in Austria, Canada, and in Poland. Each pair, so each satellite carries a filter, so each pair has a blue and a red satellite. The telescopes are only 3 centimeters in diameter, and the field of view of the CCD is 20 times 24 degrees, but we don't read out the whole CCD, we read out rasters of selected stars. The reason the field of view was chosen that way is because the scientific goal is to observe the brightest stars in the sky. And to do differential photometry, you need a statistically significant number of comparably bright stars. So this is why the field is large, and this is why we only read out the selected stars in the field of view. And right now, we go down to 4.5 magnitude in V. And as I mentioned before, to interpret the data, ground-based observations are coordinated, organized in a way. The good part in Bright is that with such bright stars, it's rather easy to get ground-based support observations. And if you want to know more about the mission, there is a paper recently published in PASP that describes in length the complete mission, the instrument, the capabilities, the problems that we faced in the first month, and you can also contact any BEST member or if you are interested. Just to give you a short view of the Bright sky. So Bright, what you can see here. Do you see that? Yes. Okay. So the field of view of Bright is here. This red circle. You see the sky, like Bright is able to see it, and the density, the gray density shows the amount of bright stars that are available. And so just for comparison, here is one CoRoT I, and here is the other one, and here is the Kepler field. Okay. The status right now is that on February 25th, 2013, the first pair, the 2 Austrians, were launched successfully. Then the first Polish satellite, LEM, followed on November 21st last year. Then very recently, the Canadian pair, Bright Toronto and Bright Montreal, have been launched, and it will be the fleet will be complete in August, when the launch of the second Polish satellite, Hevelios, is projected. Let's hope it will do the work. So, and really recent news, and I'm already finished. Yeah. There was a long commissioning phase. You can read everything else in the paper. One main reason was we had problems with the star trackers, and another reason was a high number of warm pixels. But in understanding these processes was important for the satellites that have not been launched at that time. So because of these effects, we have a higher effort in data reduction, so the data release is at the moment delayed. And I have to announce very sad news that Bright Montreal was launched, but obviously not separated from the launcher. So it's a loss of one satellite, so it will be actually, hopefully, a fleet of 5 satellites. And so if you're interested to join the ground-based observations team, or then please contact me or approach me this week. Thank you.
Will you say anything, Eric?
Sorry.
Not
yet.
Yeah. Sure, but those that were not already gave a talk could. Yeah.
My point will not be to present you CoRoT again, because it had been decided by the organizer that this could be a roundtable where we would try to turn to the future. And, but still, I wanted to stress one point which seems to me important for this community, because of course we have been focusing very much on future observations or on very new results. But you have to know as a community that there is an important effort which is made at the moment to make Kepler data and CoRoT data available under the most useful form and the most accessible form. This effort, of course, is going on very much at Aarhus within the KASC, and there is also an equivalent effort going on in Meudon with the latest, to do the latest correction for the CoRoT data, and to present them in catalogs and in a way which is accessible to the largest community, not only this community now, but also the community as it will be in a couple of years. And if you want some information about this, we have a few posters about the CoRoT work which is done at the moment on the data on the archive and the latest corrections and so on. These are posters 48, 49, and 50. No, 88, 89, and 90, sorry. And in fact, this activity goes beyond CoRoT or KASC groups, I would say. Because at the European level, we also have this spacing project. A lot of you know about it already. Did I spend my time? Thank you. So at the European level, we have this spacing project in which many of you are already involved, but maybe not all. That's why I'm stressing it. Spacing project is a FP7 European program project, which has started last year, and with the main aim, to make it short, to valorize, I don't know if it is really an English word, but maybe to help valorization, not sure it helps, of space, to validate? Well, okay. It's not exactly what I meant, but we'll do it. Anyway, to make the best use, to allow the best use of the data which have been obtained from space. It was the general words used to describe those data, and from the ground, within all this long-term time variation activity which has been going on in the past years. So if you want some information about it, and there are some visibility work to increase visibility and access to this data through web portals, through databases, a lot of work, and there is a brief description of this spacing project on poster 87. And well, I think that's all for me at the moment.
Thank you. So, of course, this is a round table, so, and you're sitting straight here, but The intention is that there should be a discussion between the different members. And also, if you have anything that you would like to ask or point out, you should, of course, raise your hand. But I think we will start with the panel here. Jamie, you would like to say something?
So, continuing in Eric's theme of looking towards the future, and the theme of this roundtable, and also extending on Constance's introduction of the bright constellation, I just want to point out that, one, there is still the possibility that Bright Montreal, the second nanosat, might still be salvageable. Ironically, the deterioration of the restraining cable due to radiation damage and atomic oxygen may eventually release it from the third stage of the Russian rocket, and not that far into the future. And if it is, then NORAD would track it, and then we would contact it. It would be in a higher orbit, about 1,100 kilometers. So there is still hope for Bright Montreal. The other good news is that Bright Toronto is performing extremely well. Within a week of launch, we were obtaining science commissioning data, and we've been getting beautiful photometry with it on, I believe, the Centaurus field for the last 2 weeks. So although the early commissioning was very prolonged, we learned a lot of lessons from that, and so the commissioning of our latest Bright and the second Polish Bright, Heveliusz, we anticipate will also go very quickly. The future, I invite any of you out there that are interested in joining Bright, not just as a potential user of data, but as a partner. The price tag for a Bright nanosat is about $1 million, about 700,000 euro. And we could always use more, and possibly ones with ultraviolet filters to complement the blue and the red filters that we're using now. In my other, putting on a different hat, the MOST mission, MOST is still going strong after more than 11 years in space. But what might end the mission is our government. They are pulling the plug on funding the operating costs of MOST, which are about 200,000 euro per year as of September. I'm looking for other funding sources, other agencies, companies, private donors, kickstarting, crowdsourcing. I'm passing around a hat amongst there. So I've calculated that if every one of you contributes $1,000, we can run MOST for another year. Jorn, you have to contribute $5,000. But if do keep that in mind, if we have support in the community, for those of you who are American scientists, if we are proposing to NASA to take over MOST, part of it is to show that there is a vibrant user community and an oversubscription rate, which there would be. So do keep that in mind. I'm confident that the MOST mission will continue, but there might be a hiatus. I'm not confident we'll have funds in place by September, but we are not shutting down the satellite. We're just putting it in hibernation, and it can be reactivated, and our mission plan extends beyond 2020. And so we have the potential to be a transition between the CoRoT and Kepler era, along with K2, to take us into the TESS and the Plateau and the Cheops era.
Good. So, yeah.
I'm not very good in calculating so quickly as you are. So how much money would you need on a yearly basis to keep MOST running?
The $300,000 Canadian, which at the current exchange rates is about 200,000 euro per year, assuming we operate it with the full capabilities that we have now. We do have other scenarios where we could reduce the number of target field switches and so on, and could reduce that to possibly something like about 120,000 euro per year.
Yatim?
One thing that occurs to me among all the wonderful news we have, a thing that I think will limit science is the K2 not providing light curves. And so I wondered whether the panel have any plans. Martin mentioned $2 million is going to guest observers. I mean, if I were running this, I would devote some of that money to actually provide light curves, because I think the amount of science that will come out of the mission would be enormously increased if that were to happen.
You're a fantastic straight man, Tim, as many people have often told me. Yes, we did not get the full funding that we asked for through the senior review. We were given an operational budget which is 90% of what we required to do everything that we wanted. And there were only two places in which to find the missing 10%. One is providing money to the community to do science. The other was developing, maintaining, and running an operational pipeline. The guidance from NASA headquarters is currently not to penalize the community. So that means it's only coming from one place. And so the people running the Kepler pipeline are under an enormous amount of pressure to find a way to produce light curves in a way under a very constraining budget. And I think they're finding it very difficult. And so, you know, there are two possibilities here. One is they find a way and the light curves will start to flow at some point in the future. The other possibility is the project will just say, you know, we have a huge community out there that are perfectly capable of performing the same algorithmic operations on data. And maybe that's the right way to go. Maybe we should be spending the money elsewhere. And I don't know which one it's going to be, to be honest with you. All I can say is that when the campaign 0 data arrives and the campaign 1 data arrives and the campaign 2 and 3 data arrives, they're not going to come as light curves. They're going to come as calibrated pixels. And so indeed, one of the things I was hoping we would do at this round table is try and brainstorm and think of plans and identify individuals and identify groups who are interested in using pre-existing software that they may already have and would do a perfectly good job on K2 data, or identify people who are willing to help develop in an open source, in a fully shared way, a series of algorithmic tools that everybody can use or everybody can exploit in some way or another. So if anybody wants to chip in, provide suggestions. We already have an open source project at Kepler, of course, which is Pike. It's really good at some things. It's fairly basic at other things. It's really understaffed. It's just myself and Tom Barkley in our spare time trying to contribute to it. All of the K2 examples, the commissioning data, the light curves, the precision, the transit candidates that I showed have all been produced with that software. And Tom is going to have to take a lot of burden on his own shoulders to get what he's been working on into the public domain over the next few months. And you need to clobber him until he does, because he'll only listen to me for so much longer. He needs some community pressure to get that stuff out there. But he also needs a huge amount of help. This is an open source project, and as many people who can contribute to those tools, the better it's going to be for everybody in the long term. But yeah, open to the floor. Who can help and who can contribute to this?
I just want to say that if this will not be done by you, it will be done 100 times by 100 groups, and this is definitely not a good use of time doing the same thing 100 times.
Yeah, I agree. Which is why we need to organize. We need to be open, and we need to have a channel of communication. We need a supergroup, wikis, and that kind of thing, so that we only do this 1 or 2 or 3 times, and we find the best way to do it. We haven't even identified the best way to do photometry extraction. I mean, we've tried a few things. Some have been successful, some have been unsuccessful. But there are many ways to do this, and we need help figuring out how to do this and to get software in the public domain.
Yeah, well, getting the light curves isn't a problem. We already have the tools for that. aperture curves, shall I say, aperture light curves, is finding ways to minimize the error, finding clever ways to improve the precision. That is the real problem. And that's where we need a think tank to exchange ideas, because unless we exchange ideas, we go along and waste time in different directions, dead ends, and we need to form a group to exchange these ideas. I mean, getting the aperture photometry itself is absolutely trivial. It's getting the precision as best we can. That's so important.
I'm not sure I'd agree, Louis, that getting the photometry is trivial in terms of the artifacts and the nature of the data collected in the K2 mission is different than from Kepler. So a lot of the experience that we have from Kepler, while it's valuable, is not sufficient to produce the optimized light curves for K2. But I do agree with you that you know, in some sense, having a pipeline to produce the light curve may be you know, the simplest task, but it's a task that still hasn't been laid out very clearly, either by NASA or by the community.
Yeah, I kind of hear what you're saying, but I want to echo what Jamie says. Extracting pixels is easy. Extracting the right pixels is an optimization process. Whether you want to weight pixels is a question to answer. Whether you want a mask to move with the source is another question to answer. There's a whole bunch of switches here that we need to play with and that we need help with. So that's one of the problems I think we need to solve. Another one is the systematic error extraction, or correction, which I think you're alluding to. You know, there are a number of ways to approach this. One is to optimize the mask, try and reduce the contaminants that way. Another is principal component analysis, or basis vectors. It's the same thing. So that's the second thing we need to worry about. And the third one, of course, is for the planet people, is transit detection itself. I think those are the three main areas that we want to figure out.
Suzanne, and then Mark at the back.
So I just want to make 3 points briefly. The first one is that there are a number of groups trying to do K2 photometry outside of the K2 team itself, and it would be, as several people have said, it would be very helpful to organize. And so, you know, I'm wondering whether you have any plans to set up working groups that have telecons and that have meetings, etc. So that's point number one. Point number two is we'll develop tools, but we probably won't have the manpower or, in fact, the required set of skills to consistently deliver standardized light curves. And that is something, you know, there's one thing is algorithm development, the other one is just making data products that everybody can use in a standardized way. And the third point escapes me, so I'll just have to clamor for the microphone again.
Mark?
Yes, I think you're raising an important point that a lot of these large projects are going to have to face. I mean, in Apogee, for example, we have a large spectroscopic survey, we have an automated pipeline for analyzing the spectra, and we're having a serious discussion about releasing software tools, and I think we should and intend to do so. And so the thing here is it strikes me like you have two fundamental avenues here for the Kepler K2. One of these is, in effect, to argue that this is a component of mission closeout. That is to say, providing a public tool that people can use, a public release software that people can use as a piece of what the mission should deliver. And the other is to say that we have to investigate some kind of a collaborative approach like to astrophysics data analysis, NASA ADAP, as a funding agency. In either case, you need to have funds and you need to have people. But I think in one way or another, whether it's through the grant process or through the closeout process, I think we need to have a tool to deliver that lets people make efficient use of the light curves.
Mark, just quickly, option one is not on the table. I'm on the Kepler Executive Council. The closeout for the Kepler mission, we have a tremendous amount to do in the timetable to deliver essentially our best estimate of Eta Earth. And you're familiar with the challenges that we're facing to have the revisions to the Kepler input catalog in time for that. So there are no resources as part of the actual original Kepler mission to provide this kind of pipeline. So I would say, and Martin can verify whether I'm right, that that's just not on the table.
It's not on the table.
Question to Martin. Martin, we have seen some data results already for K0, K1, so it means that the pipeline is still used at the moment or not? Or did you produce them?
So those results were produced with the existing open source software, which are on the guest observer pages, which, you know, again, we've been encouraging people for many years, multiple CASC meetings now. We've been standing up and talking how important it is for people to understand their data, make their own light curves different ways. Not just for this reason, just because the pipeline itself does not necessarily produce the best light curve for your purposes. It produces the best light curve for its own purposes, and it always will. And there's just been, you know, here we're now suddenly in a situation where people probably cannot rely on it anymore to make good light curves. And so everybody has to change direction a bit. This is a momentum shift. You know, K2 is going to supply data of the same kind of quality, but it's going to be down to people to do perhaps what they should have always been doing, is to make the best light curves for themselves.
I think we should, Victor in a second, but we have CASC, and there is a steering committee for CASC, so of course it's obvious that that should now be discussed on the CASC steering committee, how we deal with this, and instead of people just randomly start to organize this. So the board or the steering committee should, of course, very urgently take up that discussion and find a solution and find the people who are willing to help with that. And there may or there are surely resources also around that can be put together. So I at least suggest that that is the first thing to happen. But Victor?
Yeah, thanks. Actually, we started the discussion, of course, in the Working Group 8, in the Red Giants of CASC team. We made a call, actually, for members of the community to help on this. We got actually a very good number of replies, and people are starting to work on it. So if somebody else is interested, we have a Working Group 8 meeting tomorrow, during lunch break in the little room where we will discuss this approach. And Martin, actually, you should show up there in case you forgot.
I'm mindful that time is moving on. I just wonder to shift the discussion. Do people have any questions in particular for George and Heike in relation to TASC?
Yeah, I'd like to raise a different topic that's actually related to community involvement, which is going to be a major impact for TESS, Cheops, and Plato. And that's this issue of precision radial velocity follow-up. I think the experience from both CoRoT and Kepler is that that's one area where the richness of the missions will not be achieved unless there is that matching capability from the ground. And you know, we've worked very hard, both for TESS and for Plato, to provide brighter targets with the idea that the radial velocity follow-up will be easier than it has been in the past. But if the new generation of instruments, the 10 or so that I mentioned, and I'm sure there are others as well, if they don't come online in time, there's going to be less total scientific output from these missions than there could be. So that if we can, as a community, work together to provide support, political, financial, whatever it takes, for the different organizations that are assembling these meter per second systems, we, you know, the full capability of TESS and Plato in particular will not be achieved. And so I'd like to, you know, urge that we consider this as something that's going to be important to all the missions in the future.
Let me briefly add to that, because we're in the middle of this Bright Constellation mission, and I can see already, I'm chairing this, I'm just giving this ground-based observation team, and I'm just giving some guidance. But it was really amazing to me that people got interested really quickly, and they set up teams and the collaborations. We just said, if you meet other Bright PIs and can set up your own collaborations and you can get into contact. And it's really amazing since we started how many fruitful collaborations have been built. So we are seeing this right now, and we are looking forward to now the next step, so really combining the bright data with the ground-based data. So I think it's an opportunity for a lot of people to work together, and it's beneficial for science. So I think it's very, very important. And we've seen that with CoRoT MOS.
Ennio, do you have any comments about the ground-based? Oh, sorry, Heike first.
Maybe just to add for the Plato team, people who are interested in participating to the follow-up, our coordinator on this issue is Stefan Lidry, and you should send an email to him then if you want to be involved in this.
Yes, one other comment on this particular topic that I think is really being made clear by efforts like Stefan is carrying out for both Plato and for TESS. But the realization that for the bright targets that we're going to make available to the community, you don't necessarily need an 8-meter telescope, you don't even necessarily need a 4-meter telescope, but you do need lots and lots of nights of time on a very stable spectrograph, and even telescopes that have more modest apertures in the 2-meter range, 1.5-meter range. They're quite able to make these contributions, and so many times for planning groups at the different observatories, they're looking for an instrument that's going to go on an 8-meter telescope or something, 6 or 8-meter telescope, and they're going to say, well, oh, by the way, you're only going to get 40 nights a year. That's not the place where the maximum amount of advantage can come from what TESS and Plato will be able to provide.
If I can add my 2 cents to the discussion, I would like to stress 2 points in there. The first cent is about the availability of the so-called small telescope. But small is a bad definition, but because small was 50 centimeters 30 years ago, now small it is 4-meter telescope. So there are some. I would like to stress that there are many observatories in the world that are very close to be closed because they are problems of funding and they are pressure for other projects. And we should not forget that we have a good, if your observation are connected with a space mission, you are doing some frontier research, and a lot of small telescope, 4-meter telescope also, can be devoted to a dedicated project. And this is a pressure we have to do in our countries, do not lose this possibility to devote the telescope near to be closer to a specific project, having the perspective to give results for a long year. And the other cent is about still the fact that you have doing frontier research. So do not hesitate to ask to committee about observing time with new generation telescope, because actually you are pushing the limit of observation. You are again further. We have seen results here that are very challenging for theory, and then you have instruments that are used maybe for other projects that are a bit constructed, built for other projects that can give you the answer. So do not hesitate to propose observation with a challenging instrument. For instance, when we built the Plato Consortium, is asked us to demonstrate that the observation made by Plato can be fulfilled, can be better results can be obtained if a ground-based facility exists. This was an asset. This was a work we had to do, and we did it. But do not forget now that we have the possibility to reverse the possibility. If you have space observation, you have the kind of observation which are able to exploit fully the spectrographies, the instruments that are built. You can reverse the game and say, well, we built an instrument, you need candidates, we have the candidates. So use this instrument to make this kind of research.
Maybe I can say a few words which are not completely in the same direction as Ennio, but I would like to say that one of the advantages of turning to bright stars are the future space mission are going to do, is that also we can benefit from the existing archive. So doing new observation is something good, and in some cases we will need them. But on the other hand, we have a lot of existing data, we have a lot of high resolution spectroscopic observations which exist, and we have not to forget that, and it will save also some telescope time. It doesn't mean that follow-up observation will not be mandatory, but it will allow us to concentrate on our effort on some well-chosen targets, and we will also get information on the targets themselves by digging in the archives and analyzing them.
Yeah. Is there any urgent lessons learned that you would like to, for some of the missions that have already experienced successes in space, that you would put on the table that the coming missions should learn, Eric or Martin?
It's easy. Software. Okay, you are all now in a significant bind because the software has been developed behind a firewall. Kepler was originally a PI mission, and the software concept was designed to serve that PI. And as time has evolved, Kepler's become more and more of a public mission, and it's now K2 is a completely public mission, but now it does not have a set of software, a set of tools to serve you guys. And we're now going to struggle, but hopefully succeed in solving this problem with your help. But it's clearly the major outstanding issue for the K2 mission in my mind.
I think one of the lessons has already been learned. If the presentations that you heard from George on tests on Plateau and so on is, I think what we learned with CoRoT, with Kepler, is they were all designed to do originally specific things, and they ended up doing things far beyond the original plans in ways, in many cases, very different than the operational plans. And you're seeing that already in tasks in Plateau, that not restricting the science to a very particular type of science. But I think there's still opportunities that I would just encourage everyone to familiarize themselves with the capabilities of those missions and find the niches that have not yet been put in the science case, because they're there. And it may be up to you to exploit them.
Just to add to that, you're absolutely right, but also it's important, especially for K2 and maybe other missions as you go ahead, is that people are struggling to propose the obvious, not just the inobvious niches, the innovative niches. We struggle to find people to propose the brightest stars in the field for new planet discovery, because people thought it was too obvious. People thought there's going to be people doing that. Why would I bother? There was nobody doing it. And so don't be afraid to propose to do the obvious and the simple, because otherwise we're going to miss big, huge open opportunities.
I thought I had that market wrapped up.
Yeah.
I think Eric went.
Thank you. In the same spirit, even if on another side, I would say that I would like to share some ideas with you, which are inherited from CoRoT and Kepler, I would say. As just mentioned by Jamie, it's obvious that when you start looking at thousands of stars for a long time, you discover a lot of things, and not only what you aimed at initially. But in my opinion, as a community, we also have to be aware that it seems to me to be aware that CoRoT, like Kepler, were first-generation missions in terms of long-term, with most. First-generation mission in terms of long-term photometry observations. We knew it could help in the problem we wanted to address, but we lacked a lot of experience. Now we have this experience in terms of techniques, but also in terms of the object we are looking at. And this already can be felt in the fact that the new generation missions which are discussed now, like Plateau or TESS, are already much more specific in terms of duration, coverage on the sky. As George said, we can see that there is it is appealing to try to look at all the sky for various reasons. And so we are becoming more ambitious, but also, in my opinion, it is the start of an evolution which makes that we are no longer talking only on about stellar seismology, but what was named a few years ago time-stellar astrophysics, which means that what can you do when you have long observations. Usually, maybe you heard about the 3 criteria which were mentioned during the discussion this morning. This was coverage of the sky, duration of the observation, and sampling. And I think this is the most obvious characteristic of this kind of surveys. And in the future, I would say that as soon as you make a survey, you will have a lot of return, but you can try, or we will have to optimize those 3 parameters for specific targets, for specific objectives. And one of them, in my opinion, will be red giant. We can think about red giant one day. And then if you think about seismology of red giant and use of seismic indices, what do you want? You want an all-sky survey, because we heard this morning the relation, the strong relation between red giant seismic indices and what can be done in galactic study. So you want an all-sky survey. You want long duration, because you want to extract the indices which are very narrow in frequency or period spaces. And you want a sampling enough to get, you want a reasonable sampling. So we made, just for your information, of course it is not, we are full of projects at the moment, so we cannot think about having more. We do not have any perspective. But I think for the future it's an idea to have in mind. We made this exercise with a few people around here last year in a prospective of CNES, this exercise to try to see what we could propose for an all-sky survey dedicated or optimized for seismic indices, and it is poster 90 this time. So for those who are interested, it is a way, as mentioned by George, one way to increase coverage is to increase the field of view. Here we try another concept, which is a rotating field, a rotating platform. And you will see that somehow it seems that it can work. And to get you, just to give you a number, to attract you to the poster, and to keep the idea in mind for the future years, the idea would be to give seismic indices for 500 million, sorry. I want to attract you, but I have to do it. Honestly, 500,000 red giants, all around us, full sky coverage, 8-minute sampling, and 6-month observation within the core mission, which would be something like 4.5, 4.5 years, and 10-month observation after 7 years of mission, which gives you the delta pi index we want to discriminate stars on the clump and on the RGB. Okay, there are probably a lot of problems to achieve this, but I would like you to have in mind that one day we may propose something like this. Thank you.
We should probably, I think, wrap up at that point. So could you join me in thanking the panel for... Please do take the opportunity to, again, pick up on and continue the discussions that we've started in this forum. I have, sorry.
May I say a few words about the chaos?
Yeah, just quickly, yeah.
Because before we finish this panel, I will draw your attention on the CoRoT mission, which was going to be the first small-size mission led by ESA. The PI is Willibend, it's led by the Swiss, in fact, with in European collaboration. But it's going to be a kind of follow-up mission, aiming at detecting planets in already known planetary systems, so inner small-sized planets in the range of super-Earth to Neptune size. And also it could be used to better characterize the small-sized planet already known. And my message is that 20% of the time of CoRoT will be open to the community through a peer review, a competitive process, of course. But the launch is scheduled for 2017, so you can get prepared, and the instrument will be pointed anywhere in the sky, and you can prepare your list of favorite target and think about applying to the KOPS open time. So,
Thank you. I had just one announcement before you all dash off for lunch. If you're interested in the APA-KASC collaboration, that's the collaboration between Apogee and KASC, there will be a meeting at 1:30 on Friday in relation to that. Okay, thank you very much.